The phrase comprehensive design really arose out of the need to properly position sustainable design within the typical design framework. In our formulation was form, function, plus sustainability. So we were trying to show that sustainability is a part of the overall design activity. It's not something alien to what designers can do or should be doing. What we're doing at Art Center is a streamlined life cycle analysis. The life cycle analysis method consists of 3 steps. First, you do what is called a process tree. And that is basically a graphic representation of all the steps that it takes to get to your product or system. You also have to show and account for all of the material and energy inputs and outputs for every one of those steps. So a great deal of research goes into this process tree. Your life cycle analysis is only as good as that original process tree. And it looks very much like a tree. It starts with raw material extraction and usually ends up with disposal. And you have going into and out of each of these steps, whether it's packaging or manufacturing or assembly or use or maintenance, you have materials and energy that are parts of that activity, and then material outputs. You might have emissions to water, emissions to air. Once you do a process tree, you now take that data and you put it in a table, and it's called an inventory matrix. And it's basically a chart that shows the steps of the process, and then you list now what are your inputs to the steps, what are your material inputs, what are your energy inputs, how much energy is used, and what are your outputs. The hard part comes with the 3rd step of the life cycle analysis, and that is the impact matrix. Now we have to look at the data that has been collected on this inventory matrix and draw some conclusions. What does high energy use in manufacturing? What impacts are associated with high energy use in manufacturing? Is it reduction in biodiversity? Is it global warming? Is it ozone layer depletion? Is it emissions to air, emissions to water? What are the impacts of these inputs and outputs to the system? Students have to determine what the inputs are and what the outputs are, where the high energy cost is, what the different steps are. They generally do a very, very good job of describing these process trees.
The biggest challenge was looking, car seat is such a complex product, so the biggest challenge was looking at all the components and processes that go into manufacturing of today's seats, and think about how we can make it much more efficient. So my goals and in final design, I was trying to synthesize all the materials and processes to at the end make it much more efficient and user-friendly, and aesthetically pleasing and engaging for the customer, and then take it even farther from there, and add life cycles to the product at the end of the car. So the 5 goals that I focus on was first, biggest cutting weight, material optimization, elimination of toxins, life cycle extension, and design for disassembly. Cutting weight was the biggest one of the goals, and that came out from the life cycle analysis, as well as interviewing, talking to the experts in the field. And the way I met this goal was to kind of reconsidering the material choices for the product. So the structure and the cushion were the two biggest parts of the seats, and the heaviest. So I focused first on the structure, and that structure today is made out of 30%, or one of the more sustainable, I guess, seats is made of 30%, around 30% of steel and 70% of aluminum. It's extrusion, so I changed that material into composite, but a composite that it's 100% recyclable. So it's made of 100% of polypropylene. So even though it is still a composite material, it's at least recyclable at the end of product life. So that's one thing, and then another component that needed to be addressed was the cushioning. So right now a lot of car seats are made out of polyurethane foam. More sustainable car seat incorporates some of the soy-based polyus into making the foam as well. So you have percentage of soy-based polyus and PU in the mix. The way to eliminate that, I used a warp knitted spacer fabric, and I actually used some of the research from a university in China that study the comfort level of PU foam and the spacer fabric to establish, if the textile is stable enough to provide some of the bounce kind of prevention during the ride. One of the other important goals for me to meet was material optimization, because there's so many components and materials that go into existing car seats. So what I did, I looked at the cushion and the upholstery, and right now, it is, let's say, I consider it to be part soy-based polyus and part polyurethane. And then for the cushion, and then for the upholstery, I actually researched vegetable tanned leather, which is more of a sustainable choice for leather finishing. So I took those components and I really wanted to optimize that. So what I did is I tried to use the warp knitted spacer fabric as kind of a hybrid, because that fabric already has the textile, already has the finished layers on both sides, and has the cushion inside. So that not only provides a finished surface, but also provides quite a bit of breathability, which is a great kind of advantage to the comfort of the seat. Yeah. Another one of my goals was life cycle extension, because right now manufacturer car seats are considered to last probably 100,000 up to 100,000 miles, and 10 years. Of course, some of them last longer, but as far as designing and think about materials and process that go into it, can we extend that life of the product even longer than that? So since I'm using a composite for the structure, and it is still composite, so a lot of energy goes into production of that material, but it's also very durable. So I was considering taking that, reusing the structure of the seat, and detaching it from the base that is mounted into the car interior, detaching that, and then reupholster it with a new material, establishing with city government, public buildings where those structures could be reused. So let's think bus stops, even buses themselves, airports, any public government buildings where public seating needs to be provided. This structure could be then reupholstered and replugged into a larger seating system. Another goal was designing this product for ease of disassembly. So that thinking of that, all the connection were designed to be mechanically connected together and assembled for ease of disassembly. And the different materials were labeled clearly, so once the product is disassembled, it's kind of very easy, a fast way for you to group the materials into the recyclability possibilities later on.
as I said at one time, that what designers do is we visualize the future and then we design for that. And because that's what we do, we basically enable that future to exist. So if we envision a sustainable future, let's design for that, and then we will therefore participate in making that future happen.